Assalamu alaikum everyone, dear students. I hope all of you are doing well. We are starting arithmetic and geometric sequence of paper 1 of A-level maths. You can see the definition of arithmetic sequence. Basically, it is a sequence in which the difference of any term and the previous term must be a same number. You can see that an and an minus 1 will be a same number for all the sequence. So an, it can be any term, and an minus 1, it will be the previous term. For example, if an is 10th term, then an minus 1 will be the 9th term. Similarly, if an is the 20th term, then an minus 1 will be the 19th term. So the difference of any term and the previous term must be a same number for all natural numbers. This symbol means for all natural numbers. Now the difference between any term and the previous term, it is called a common difference. You can see from this sequence that the common difference is 3. If you subtract 4 and 1, you will get 3. Similarly, if you subtract 7 and 4, you will get 3. Similarly, look at other sequence. If you subtract negative 7 and negative 4, you will have this thing. So that will be negative 3. So the common difference for this sequence will be negative 3. Now you have some important formulas regarding the arithmetic sequence. First of all, you have nth term. Basically, first term, it is usually denoted by A in case of all types of sequences in A-level mathematics. So if first term is A, how will you get the second term? You will add common difference in each term to get the second term in case of arithmetic progression. If A is first term, and if you add D in the first term, you will get the second term. That will become A plus D. Similarly, if you add D in this term, you will get D plus D. That will become 2D. So this will become third term. Similarly, you have third term A plus 2D, fourth term A plus 3D, fifth term A plus 4D. If you follow the same pattern, you will get the nth term or any general term. That will become A plus n minus 1D. Similarly, you have formula for sum up till n terms. It is basically first term plus last term. You can also say A plus an or A plus L, multiply by n by 2. Now you have seen the expression for nth term of the sequence. It is basically A plus n minus 1D. So if you add this one, A plus A, this will become 2A. So this is the expression for sum up till n terms. And you can verify this formula using any sequence. For example, if you have this sequence, look at this sequence. First term is 1 and the difference is D in case of this sequence. Now we want to verify this formula, and we are adding just first 4 terms of this sequence. You can see that first 4 terms of this sequence are 1, 4, 7 and 10, and the difference is 3. So because you are adding first 4 terms, n will be equal to 4. If you substitute all these values, n will be 4. A is first term, which is 1, and n minus 1 will be 4 minus 1, that will become 3, and D is the common difference. This is also 3. So if you sum up, if you simplify these calculations, you will get 22. This is the number 22 you are getting using this formula. But if you add first 4 numbers without using this formula, you will get same thing. 1 plus 4 plus 7 plus 10, that will be 22. So these are 2 very, very important formulas for the arithmetic progression. You also have these formulas in your formula sheet, MF19. This is formula for the nth term, and this is formula for sum up till n terms. Now you have another type of sequence. This is called a geometric sequence. I have explained in previous part that what is an and what is an minus 1. An is the general term, and an minus 1 is the previous term to the general term. If you divide any term with the previous term, you will get a same number for a geometric sequence. So in case of a geometric sequence, if you have an divided by an minus 1, this will be a same non-zero number for all natural numbers. And in this case, the division of an and an minus 1 will be called R, the common ratio. You can see that in this sequence, if you divide 4 and 2, you will get 2. Similarly, 8 by 4 will be 2. 16 by 8 will be 2. 32 over 16, it will be 2. And similarly, in this case, 22 over 24, that will be 1 over 2. 3 by 6, that will be 1 over 2. So the common ratio will be 2 for this sequence and 1 by 2 for this sequence. Now, basically, there are two types of geometric sequence. You can have a convergent sequence or a divergent sequence. First of all, let's discuss the convergent sequence. Basically, the absolute value of R must be less than 1 for a convergent sequence. From these two sequences, we can easily see that this sequence is basically a convergent sequence because any number is basically less than the previous number. You can see 12 is less than 24, 3 is less than 6. So this is basically this type of sequence that is basically converging to a specific limit. So this sequence is basically a convergent sequence in which absolute value of R is less than 1. But sometimes the common ratio is greater or equal to 1, and sometimes it will be less or equal to -1. That will be a divergent sequence. Now this is a divergent sequence. This is this type of sequence that each term is basically greater than the previous term. So it is diverging. So there are two types of the sequences of a geometric sequence: convergent sequence and divergent sequence. Now we have some important formulas regarding the geometric progression. I have already told you that in all types of sequences in A-level math, the first term is usually denoted by A. This is our first term, and if you multiply R with any term, you will get next term in geometric progression. So if you multiply A with R, you will get AR, the next term. Similarly, if you multiply R with the second term, you will get AR square, the third term. Similarly, you will have AR cube, you will get the third term. And if you follow the same sequence, you will get nth term of the geometric progression. It will be A times R to the power n minus 1. Now we have some expression for sum up till n terms. This is sum up till n terms if R, absolute value of R is less than 1, and if absolute value of R is greater than 1, this will be sum up till n terms. For example, we are going to sum these 4 terms of this sequence, so n will be equal to 4 because we are adding first 4 terms. Now we can use this formula because all right, this is basically R minus 1, not R plus 1. All right, now we are adding first 4 terms. A is basically first term, which will be equal to 2, and R will be 2 in this case. N is 4 because you are adding first 4 terms, divided by 2 minus 1, and 2 R is basically 2, so you will have 2 minus 1, so 2 to power 4 16, 16 minus 1 15, and 15 twos are 30. So if you add first 4 term of this sequence, you are getting 30, and you can verify this calculation. If you add first 4 terms of this sequence without using this formula, 16 plus 8, that will be 24, plus 4 28, plus 2 30. So you will get same number if you add these 4 terms. Now we have sum up till infinity, and it is basically only for the convergent sequence. You can see from here sum up till infinity only for the convergent sequence, because divergent sequence, in a divergent sequence, any term will be greater than the previous term, so you cannot have the sum up till infinity for a divergent sequence. All right, we have seen this expression for sum up till n terms from here, and if you have a convergent sequence, in case of a convergent sequence, you can see that R is always less than 1. the absolute value of r is always less than 1. Now let's have an example. For example, r is 1 over 2. If you have 1 over 2 to the power 1, that will be 0.5. 1 over 2 to the power 2, that will be 0.25. Similarly, you can see that if you increase the power of 1 over 2, the result is decreasing. So if you extend the power of n up till infinity, ultimately the result will approach to 0. So we can see that if n, it is basically so if n approaches to infinity, then Rn will be approaching to 0. You can see from this example. So when Rn approaches to 0, you will have sum up till infinity a times 1 minus 0 over 1 minus r. So this will become sum up till infinity a divided by 1 minus r. Now we will solve some examples regarding the arithmetic and geometric progression.